Good morning. Lesson 5-1, powers and exponents. So today we should be able to write a product of whole numbers, fractions, or decimals as a power, and be able to write a power as a product of factors. So what are we talking about with factors and products? Here's what we're talking about. These are factors. They're numbers you multiply together. Those are called factors. Here you'll notice we have 4 of them. 4 then becomes the exponent when we write a power, and the base is the factor that you multiply together. This whole thing together is called a power. The base is the factor that you multiply together. The number of times, like how I like to say it, the number of times you write the factor is the exponent. So if we practice down here, this whole thing, so the brackets mean whole thing, this whole thing is called the power. These, as a set of somethings that you multiply together, those are individually called factors. Now what are the factors that we wrote? 10, and that makes it the base. How many of those you have, how many of those factors that you have is your exponent. Exponent. That's a long word. Exponent. Oh, I think it's long, not as long as I was expecting. Okay. That's your terminology. So over here on example 1, write 7 times 7 times 7 using an exponent. Okay, well the base is the factor that we wrote. What's the factor? 7 is used as a factor how many times? How many times is it out here? 1, 2, 3, 4, 5. That means all of this can also be written as a power 7 to the 5th. So we would say 7 to the 5th power or 7 to the power of 5. So in this case, what's the factor that we have listed here? 8. That's the base. How many times do we have the factor? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's your exponent. 8 to the power of 10. This does not equal 8 times 10. That would be different, don't you think? 8 times 8 is 64. If we times it by 8 again, it's going to be more than what we want. If you do this on your calculator, you could type in 8 times 8 times 8 times 8 as many times as you need, or on this particular calculator, it has this button called a caret. It's this guy right there. It looks like a rafter. Okay, that's a caret. 8 to the power of 10 is actually worth 1 billion plus some change. It gets very big very rapidly. So you can see it wouldn't be 880 because that would be far too little. Okay, let's move on to try it with not whole numbers. Here we have some fractions. In this case, the base is 2/5. And we wrote it 1, 2, 3 times. So the power is 2/5 to the power of 3. Notice that the fraction is in parentheses. You need to do that. If you don't, the power will attach to the numerator only, but we need to attach it to the entire fraction. So we have to put it in parentheses. Same as here with the mixed numbers. So what's the factor we're writing over and over again? 1 1/2. That's your base. How many times? 1, 2, 3, 4, 5, 6, 7. 7. Now we have some kind of fancy ones, fancy powers. If it's to the power of 2, so you could write to the second power to the power of 2, or this means squared. Here's the reason why. When you are finding the area of something, let's say this is 4 meters and this is 3 meters. The area is length times width or base times height. This would be 3 meters times 4 meters. 3 times 4 is 12. Meters times meters is meters squared. Squared. That's when we find area. That's why our units are always squared, is for that reason. And we say squared because it's sort of a square shape. Honestly, it'd probably be better to be rectangle, but it works. Then if there's to the power of 3, we can also say it's cubed. So if you read or hear someone say 5 cubed, it means 5 to the power of 3. Here's why. If you have this same situation, let me grab a different color here. If you have the same situation, but it has depth, oh, purple and purple wasn't a great idea. And if it has depth of 2 meters, now haven't we created a cube? And to find the volume, you take your base times height times your depth. And now 3 times 4 is 12, times 2 is 24. Meters times meters times meters is meters cubed, because you're literally creating little cubes. That's why it's called cubed. Okay? Let's try to evaluate them, which means find out their value or how much they're worth. Value. That's what evaluate means. 4 to the power of 5 can be written as a product 4 times 4 times 4 times 4 times 4, which is 1, 2, 3, 4, 5 of them. 5 of them, okay? When you do this, 4 to the power of 5, 4 to the power of 5, you end up with 1,024. 1,024. Evaluate 8 to the power of 4. So if we're going to do 8 to the power of 4, the factor is 8. So I'm going to write the 8 4 times. 1, 2, 3, 4, and multiply in between. And then we can find its value, 8. We could go 8 times 8 times 8 times 8 and get 4,096. Or we could do 8 to the power of 4, 4,096. Both ways totally work. That's how you evaluate. Evaluate means find the value, how much it's worth. Okay, I'm going to let you be able to read that on your own. It's in your workbook. Let's try to do this one. The factor is 2/5. We need to write it 3 times. And then we can multiply. Multiply straight across. 2 times 2 is 4 times 2 is 8. 5 times 5 is 25. 25 times 5 is 125. 8 125ths would be the value. Okay, we're going to skip over here to the check. Faith is turning 12. She asked her parents to give her $2 on her birthday and double that amount for her next birthday. If she continues with this pattern, how much money will she receive on her 20th birthday? So she's turning 12 this year and she wants $2. But next year, she would double it, which means times 2. Okay, double means times 2. So her original 2 times 2. Then the next year, you have those 2 times 2. So let's write these as powers. This is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 1, 2, 3, 4, 2 to the power of 4. Notice a pattern? Yeah, they go up by 1. 15th birthday, 2 to the power of 4. Well, we got to get all the way up to her 20th birthday. So 16, 17, 18, 19, 20. Here's where our answer is going to lie. On her 16th, we'd have 2 to the power of 5, then 2 to the power of 6, 2 to the power of 7, 2 to the power of 8, 2 to the power of 9, which doesn't really sound like a lot. And a lot of 6th graders would say, oh, 2 times 9 is 18. Wrong. Okay. 2 to the power of 9 is $512. Her parents would give her $512 on her 20th birthday. That sounds pretty good, doesn't it? Exponentially increases rapidly. Okay, that's lesson 5-1. Good luck.